I would like to welcome you to the medi prosthetics product training. My name is Bernhard Kastner. Today I'm going to tell you about the medi panthera CF1 prosthetic foot. This is a novel carbon fiber foot with integrated elastomer parts. Because of its special construction, the medi panthera CF1 combines the advantages of both damping and energy storing feet, while largely compensating for their disadvantages. This means the elastomer parts have been intelligently integrated into the design of the prosthetic foot, thus reducing the stiffness of the carbon. At the same time, the missing stability of the elastomer can be compensated by the strength of the carbon. The carbon and elastomer parts are linked in such a way that they have permanent interaction, like a parallel suspension damper system in a car. Suspension and damping act simultaneously so that the user is supported and relieved. As a result of this innovative construction, the medi panthera CF1 allows the user to move smoothly and dynamically with a high level of confidence. Today I would like to emphasize two aspects. On one hand, the extraordinary stability, and on the other hand, the harmonic and dynamic walking with the medi panthera CF1. The medi panthera CF1 allows the amputee to walk in a safe and stable manner by allowing an even surface contact and the use of controlled movements. How is this achieved? The foot contains a special technology which guarantees that the foot behaves in a controlled manner from heel strike to toe off. We call this technology medi torsion flex control. This ensures that the initial heel contact is comfortably damped and that the user's forward movement is supported by the pivot principle. The integrated heel elastomer part helps to compensate for surface irregularities, while the carbon fiber provides stability. This ensures a safe and even heel contact. In addition to this, the medi panthera CF1 has an intelligent construction with a freely suspended carbon spring. This supports early full foot contact, as the spring is spread wide during the stress response and the lower part of the spring speeds up upon full contact with the ground. But the medi torsion flex control is not only responsible for reliable heel contact. The technology also improves the adaptation of the foot component to surface irregularities. The integrated heel damper permits pro and supination. In addition, the three-dimensional mobility of the hybrid material makes it easier for the prosthetic foot to better adapt to different surfaces. This is achieved through constructional decoupling of the carbon fiber layers by the intermediate elastomer layer. A survey showed that the medi panthera CF1 has very favorable scores for the important indicators for fall prevention and stability. 86% of the questioned prosthetists rated the surface adaptation as good or very good. 66% of the amputees gave the medi prosthetic foot the grade good or very good for its stability when walking on uneven surfaces. Apart from fall prevention and stability, the innovative construction of the medi panthera CF1 supports harmonic and fluid forward movement. This is also due to medi torsion flex control, in interaction with the freely suspended carbon spring. The integrated elastomers do not only damp the surface reaction forces occurring on heel strike, but also support the controlled transmission of these forces into the system. The single-piece construction of the carbon spring leads to the system's high efficiency. The elastomers also elastify the carbon. The user glides harmonically through the different phases of the gait cycle. Once the early mid-stance phase has been reached, controlled energy return is initiated. The upper and lower parts of the carbon spring approach each other until they are touching. There is a progressive increase in force. The user is supported during toe-off. The intelligent forefoot function becomes clearer if we consider a hysteresis curve. In the linear section, the free length of the spring is used. The foot is gently rolled over. In the progressive section, when both parts of the spring touch, the forefoot resistance increases and the user is provided with a controlled propulsion. Thus, the construction of the medi panthera CF1 supports a smooth rollover by using low resistance at the beginning and high resistance at the end of the stance phase. This ensures a harmonic gait and a fluid forward movement. Let's have another look at the previously mentioned survey of prosthetists and amputees. 85% of prosthetists rate the gait with the medi panthera CF1 as good or very good, which indicates the excellent performance of the system. 81% of amputees gave the rollover behavior the grade good or very good. Most users also rated the energy return as above average. Let's summarize the facts again. The medi panthera CF1 has a hybrid design with a systematic integration of elastomer parts into the structure so that the user can benefit from the advantages of both damping and energy storing foot components. At the same time, the interaction between these two materials reduces their disadvantages with respect to energy return and elasticity. This helps the user to achieve a safe, harmonic and smooth gait. You can find more information on our website panthera.medi.de. Thank you very much for your attention.